This is a ever so slightly stripped down version of the presentation that I gave at YAPC in Glasgow. The one on YAPC is probably of a much better quality of video. Sorry, Fergus. So definitely recommend you have a look at that if you want to see it again, which you may or may not do. So, yeah, I'm Ben. I work at Pirum. Quite a few of you will know me because I go to the pub with you, or I work with you, and a few both. But I like working in Perl and I like working in Git. And the first thing I got to do when I arrived at Pirum was work on migrating Cvs to Git, which is part of a much bigger project to improve all of our lives as developers at Pirum. So when I started, it's kind of as you'd expect a CVS-based development workflow. Developer works on an issue, tests in our shared environment. Once they are reasonably satisfied, as you can be in a shared environment, that your code has not produced any significant regressions, you commit it to CVS. That CVS commit triggers a review using Fabricator, so this is a post-commit review. Once that post-commit review has passed, each file is separately given a release tag, and at that point you take all the tags, all the files, tag to release, and deploy them to production. And quite frankly, it's horrible. It is a nightmare. Revision history is littered with debug changes, because once again we have a shared environment, so that's the only way we can get code onto it. Reviews on a single file post-commit mean that you have no context as to what you were intending when you made the change, which makes reviewing someone else's change incredibly difficult. You're basically just sanity checking at this point. You can imagine what it'd be like if every single one of us in this room all had to develop on a single shared common environment at the same time. The problems it produces are amazing. Because of our release process, we can't test before deployment. So really, deployment is the first time we know this stuff is going to work. And to be perfectly honest, we already know it's a turn off for potential hires, which is kind of why I, as the next hire, got to fix it. So the idea being that with Git, we get a mutable history so that we can obviously do all the things that gives us. You're all reasonably good with Git, so I'm not going to go into that too much. Users developing their own Git branches, so we don't have quite so much overlap with each other. The pre-merge of the code review, obviously, so that we can sanity check your intent, and it means that we can make more use of our automated test build procedures, such as maybe having a Jenkins build pipeline. Because we don't have a test environment, and because we have so much tooling around CVS, like automated deployment, infrastructure management, configuration management, auditing, we can't just do a kind of big bang rollout. We have to do it phased, and we need at all times to protect CVS as the single source of truth. So that's really important. That's kind of the brief that I had. So the idea is that we do, apologies for this, they should work, but the idea is that we have two-way mirroring between Git and CVS, which I will now
It's been censored.
describe to you.
I can't show you that.
I'll give you maybe a couple of hundred words. The idea being, you have a Git repository, you have a CVS repository. From your Git repository, you do work. The work is reviewed in Git. From your CVS repository, people do work. That work is reviewed through CVS using their existing tools. These two are kept magically in sync, and then you have deployment pipelines around it. So that eventually, we get rid of all the orange stuff, which was CVS, and we just have a single Git with a single deployment process and a deployment and a review tooling around it. So, simple enough, we built some new Git repositories mirroring what we've got in CVS. We then have all commits to CVS mirrored to Git on the fly. Any commits in Git, we need to mirror back the other way, and we just need to make sure they don't go out of sync. First problem I solved was the initial import from Cvs to Git. So we had about 45 at least significant Cvs modules with production code and a lot more ancillary modules around that. We had a very long conversation, grouped them all together, decided which Git repositories each one would map to, and then we used Matthias Uhlich's Git Cvs import to take the commits from each one, put it into each Cvs module, put it into our Git repository, and then repeat it on the same directory to get multiple Cvs modules into the same Git repository. What that got us was a Git history that reflected the order in which I'd imported the Git modules. So, as this example here, you've got some commits to the first module in date order, followed by some commits to the second module in date order. We want to change this so that we have them just in date order. So to do this, I needed an oxymoron. So I came up with an automatic interactive rebase, which is basically it uses the Git sequence editor environment variable to call a Perl script. That Perl script is designed to, that Perl script will call squash similar commits, which will take as its argument the Rebase script file name, remove any duplicate. Sorry, this has gone out of sync. No comment. The Git sequence editor, a one argument script, takes the Rebase script. It will then execute git log to get every commit in the repository, order them by commit date, and mark similar commits to be squashed. What do we mean by a similar commit? I'm not anticipating anybody can read this, but that's fine. The idea is that we go forward through the history, and as long as commits are in order, have the same name, and are of a similar time, so the same text of a similar time, it will assume that these are can be reliably squashed, so we'll reorder the log and then mark them for squashing. So what this means is, of the 207 separate Cvs modules that we had in our biggest repository, which actually was 200,000 commits, 36 hours later, 10% of those commits were properly squashed, which actually was a significant amount. So we have our initial import, we have a set of Git modules now that represent Cvs. What we next worked on was applying Git commits to Cvs. So this is a new tool, apply Git Branch. The idea is, you do your work on a Git branch. You then, at the point it's ready for merge, rebase it over the latest master, and by using apply Git branch, it will merge that branch into Git, and then apply the commits to Cvs separately. We only ever apply Git commits to Cvs if the branch rebases cleanly, if it will merge cleanly, and if remote is successfully updated. And this is the main thing that comes back to protecting Cvs as our source of truth. So at this point we have a tool that will get our Git commits into Cvs. The other way around, we have a Cvs post commit hook. This is a Perl script, takes the commit message and the metadata, maps and identifies the correct Git repository for the Cvs module in which you have committed, clones that Git repository into a temporary working clone, applies the changes from Cvs, pushes the changes to the temporary working clone in the Git repository, and then pushes the working clone back up to the remote. So the idea here is that your local clones are only ever going to be ahead of the remote. So if there's a networking issue, then the next time someone does this, the remote will come back up, be brought back up to date, which was one of the most useful things we did. We encountered this scenario an awful lot. So at this point, we've got a CVS commits being mirrored in Git, we've got Git commits being mirrored in CVS. We need a common lock because we need to protect against the concurrency issues that happen as people are doing this. For our apply Git branch tool, that was pretty easy. We just, at the point you call apply Git branch to apply your merge, you take the lock and free it when it's done. With CVS, we decided eventually, having done some research into how we were using CVS, to replace user bin CVS on our CVS server with an interceptor. So the interceptor is a Perl script. The client now invokes our interceptor, not the CVS binary. Our interceptor will open its own CVS server and then pass messages between the client and the server. At the point that the CVS interceptor sees the specific message in the protocol that says perform a commit or change repository, it takes the lock shared with apply Git branch, and that is what protects against race conditions between CVS and Git, because it will release that only when the actual commit, the change to repository, has been completed. That might sound like a man-in-the-middle attack to our version control system, because it was a man-in-the-middle attack to our version control system, and it was quite a headache. The CVS client-server protocol was designed many years ago. It is one of the most antiquated things I've had to look at and re-engineer. The documentation is incomplete. It took us 3 attempts at least to get this actually rolled out. Writing to std_out and std_er turned out to be quite an issue, particularly since we discovered certain modules will happily write to std_out or std_er, which is now being caught by either the CVS client or the CVS server, which does not understand your debug output. And most importantly, if you debug a broken interceptor in our environment, you break everything, including the release tool based on CVS that I needed to fix it. So one of the main things I learned from this was do not do this stuff using your own release process. It fails miserably. But we applied it, we reverse engineered it, and it worked. And for the past few months, I have not seen a single issue on it. So, after man-in-the-middle attacking my version control system and being up for 36 hours performing a massive oxymoronic rebase, I ended up with a scenario where developers now work in Git at Pirum. So we solved that problem somewhat. I have an entire development team. Oh, I'm a member of an entire development team. Wouldn't want to.
Great time to promote it.
But we do all use Git productively. We still need CVS for a while. Our release tools are still built around it. But we can use pre-merge commits. We do pre-merge reviews. Continuous deployment is still on the roadmap. We learned a lot doing this. I learned a lot doing this. We gained knowledge about our infrastructure that had, quite frankly, just been lost over the years. And we have code that we can potentially open source, given our pipeline and all of our processes. So, as Matt said, we are hiring. I know most people, the first thing they say when I'm at Pirum is, so you still use CVS? No, I genuinely do not. So if you wish to undertake this, then do let me know and I will assist in any way I can, or tell you you're crazy. And please feel free to speak to me afterwards.